potential energy of 40 joules. Imagine now that you decide instead to place the box 3 meters above the ground. By doing the same calculations, you realize that the box has now 60 joules of potential energy. The potential energy of the box is directly proportional to the height it is located at. This is why we say that the potential energy is an energy of position. You could actually label each step of the stairs with the energy that the box would have if you placed it there. But what if you wanted to move a box of different mass? How should you label the steps? Just consider a box of 1 kilogram when you do the calculations for the potential energy for each step, and then label the steps with the result.
With the result, right.
To find the energy of a box of mass m placed on a given step, you just multiply the mass of the box by the value assigned to the step. For example, for a step at 2 meters, therefore assigned with a value of 20 joules for 1 kilogram, you can calculate the energy of a box of 3 kilograms that you would place there. It would be 20 by 3 is 60 joules. The quantity we use to label the steps is called a potential. In that case, it is the gravitational potential.
Let me pause here, because I see where he was going anyway. And the only reason I pause is because, so with each step, the gravitational potential increases. And the only reason why we're using the word potential is because it's a replacement for the word if I drop this from this height, this how hard it's gonna hit.
And it is expressed in joules per kilogram.
Ding, ding.
The gravitational potential at a given position is the potential energy that would hold 1 kilogram of mass placed at that position. What you see with this example is that a potential is a property related to a position. It is not related to an object. The notion of electric potential is very similar. The only difference is that it is the electric charge of a body that is considered instead of its mass. An electric potential at a given position is the potential energy that would hold 1 coulomb of charge placed at that position. Imagine a positive charge, big Q of 5 coulomb, located somewhere in space. I want to bring another positive charge, little q, of 2 coulomb close to it. For that, I need to push the charge little q, because there is a repulsion between the two charges. Yes, they have the same sign. By doing so, I'm kind of doing like I did with the box. I'm applying a force that will change the position of charge little q, therefore giving it potential energy.
Right, to go back to
this time it would be electrical potential energy. We could draw a graph that represents this energy depending on the position of little q, a little like we did when we labeled the steps of the stairs.
I hope y'all are getting this. It always makes me feel so good when I understand stuff. Appreciate you for the follow. I didn't see who it was out there on TikTok, but appreciate you for the follow. I always feel good when I understand stuff. So he's relating the spacing between two electrons of the same charge and their position with the weight of a box on the steps and its position.
The value on the y-axis would be the electric potential energy of the charge little q. Now, if I want to calculate the potential energy that would have a body carrying any charge, I can just draw the same graph, but this time for a charge little q of 1 coulomb. On the y-axis, I have now the electric potential in joules per coulomb. To calculate the energy of any charge at a given position, I just multiply the value read on the graph for that position by the charge. The unit of the electrical potential is joules per coulomb. Yes, joules per coulomb. The definition of what it is in the units. It's the number of joules that would have 1 coulomb if you placed it at a given position, making an electrical potential a property of a position.
Okay, like he said again, electrical potential is the same as the gravitational potential of the box on the steps. Now I hope I ain't talking in too many big words and too many big terms and thought forms, because you got to use your mind to visualize this. Now, the electrical potential is the same as the gravitational potential of the box on the steps. It's a function of position rather than just charge.
Okay, let's look at a practical understanding now. I read here on this battery that it has a voltage of 9 volts. Let's see what this means. Again here we are going to use gravity to illustrate. Imagine that you have an object at a height of 2 meters, you drop it and let it land on a table